Hi, this is Specialist Getford, and I'm here with my fourth video of my portions video series. Just going over how to find portions of things, what the logic behind it is, so that I can better prime you for later math in the ASVAB. That way that when we do meet for our sessions, either video or in person, we can just get right to the applications here. So, without further ado, I just want to develop some of the intuition behind converting decimals to fractions, and I'll give you some practice problems in the description of this video below, or you can look in the classroom folder. So, converting decimals to fractions. I want to develop some of the intuition behind it, and so part of that intuition is just knowing our place values. So our place values, some simple ones are our ones place, we already know that, and our tens place and the hundredths place. If we go to the right of our decimal point, that shows us these fractional parts, and that's why this fits in with our portions video series. Is that once we go part of one, well, when we design a decimal system, instead of saying, okay, beyond the decimal point we have fourths or fifths or whatever, we keep them in powers of 10. That's why we have a base 10 number system. What does a base 10 number system mean? It means that not only is every place value a different power of 10, for example, 100 is 10 to the second power. 1 over 100 is 10 to the negative second power. Every place value is a different power of 10. How about the ones place? Well, that's 10 to the 0th power. We will go over more exponents in later videos. And also with our base 10 number system, we have 10 symbols. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I put in 10 there kind of on purpose to kind of show us that, well, if we have, a lot of people think if we have a base 10 number system, shouldn't that mean we include 10 in our list of symbols? Well, 10 is just a combination of two other symbols that we already have used. So we don't need 10. So these are 10 symbols that we use to represent numbers. Now, if I were to represent the number 42 as a collection of place values, I would have 4 groups of 10 and 2 groups of 1. I have 42, so I have 4 of those and only 2 of those. If, however, I was going 42.017, that gives me more information. That tells me that I have, well, this is in the tens place, that means I have no tens. So I would end up continuing my addition of various powers of 10. So I'd have 0 of those tenths, and I add that to 1 of those hundredths, one group of those hundredths. So 1 of those, and I have 7 of those. So I have 7 groups of those thousandths. Notice how the bottom is gaining 1 more 0 with each place value that we go to the right. Just like how the more we go to the left, we gain another 0 for each new power of 10. Okay. So that was showing us what the makeup of 42.017 is. Just one more example of that, and then we'll go ahead and move on. If I were to give you the number 3.468, that means I have 3 of those. 3 times 1 is just 3. 4 times 1/10 is 4 of those tenths. Okay? And then that 6 is telling me I have 6 groups of those hundredths. So I have 6 of those. And I'm counting that I have 8 of those. So 8 groups of those thousandths. All right. But isn't 3.468, couldn't I put another 0 there? Sure. I could put another 0 there and make that the 10 thousandths place. Oops, 1 over 10,000. But that's just telling me that I'm adding 0 groups of that fractional part. I'm adding 0 of those, 0 10,000ths, which doesn't change our value. If I add 0 of something, of course I'm not going to change the value of it. I'm adding nothing. So that's why this is equal to 3.468. Any zeros to the right of any non-zero sequence in our decimals don't really matter anymore. Numbers that have, if I had a number like 1.0002, I still need to account for those zeros there. This is telling me I have one group of 1, and I have, well, 0 of those, 0 of those, 0 of those, and 2 of those. So I have 2 groups of, let's see, the tenths, hundredths, thousandths, 10,000ths. And that's how I build the number 1.0002. All right. So that's just some of the intuition behind it. If we know a couple of different conversions, I'm sure you'll be able to figure out the rest of our conversions. Now, if I had 0.1, the information given to me by this expression here, I'll go ahead and put a 0 there. More often than not, if you have just a decimal fractional part there, and nothing in the whole values, like the 1s or the 10s or the hundreds, then you typically just put a 0 and then point whatever fractional or decimal part you have. This is giving me the information that I have 1 over 10. Simple as that. If I were given the number 0.01, well, my 1 is in the hundreds place now. Now I have 1 over 100. So what about a number that has something in both, like 0.11? That's telling me I have 1/10 plus 100th. Well, like we saw in the other video, 1/10 is the same. I could scale that up to hundredths and say I have 10 hundredths. 10 is 1/10 of 100. So these two fractions are the same value. Now I can add these. 10 hundredths plus 100th is 11 hundredths. So I want a quick way to do this. I want a quicker way to do this so that I don't have to do any addition or any conversions or any simplifying. If I have point, and I'll use a darker color for that one. If I have a 0.17, bad one. I have a 0.17. Here's the essential question. What is my lowest non-zero value I have? I'm going to write that question down. What is my lowest non-zero digit? My lowest non-zero digit is 7. Now the next question is, what place value is that non-zero digit? It's in the, let's see, tenths, hundreds. That 7 is in the hundreds place, so here's my fraction. I have 100 on the bottom there, I have 17 on top, and then I'm done. Okay, I'm just going to go over a couple more of those, just so that we can see the pattern here. Hopefully you already see kind of the reasoning behind it. If not, but the way to get there makes sense. It's a pretty easy way to get there. So that, and on the ASVAB, I want you to use the easiest and quickest way. So let's do a bunch of them as quick as we can. If I have 0.0001, 0.324, my lowest place value is the tenths, hundredths, thousandths. So I have 1,000 on the bottom. That should be the first thing we figure out. Lowest non-zero digit, and then put that on the bottom of the denominator there. Then for the rest of it, you just put the rest of the number. Now we know that 0.324 or 0.324 is less than 1. And we know, so therefore, 324 divided by 1,000, we know that is also less than 1. Our answer makes sense. But what if we had this? If we had 1.324, that number is greater than 1. To have a fraction where the number is greater than 1, we have to have a bigger number on top than the bottom. So here is 1.324 as a fraction. Same sort of process. Our lowest non-zero digit is, let's see, in the tenths, hundredths, thousandths place. It's still 1,000. My answer would just be 1,324. The only difference here is literally just whatever number I added on there, on the end. If I had 10.32400, what would that be as a fraction? Remember, my lowest non-zero digit. My lowest non-zero digit is 4. These are zero digits. They don't have a value. Those aren't going to matter. They're not going to change the value of this. So I'm still going to calculate as thousandths. And my answer will simply be 10.320, or 324, I mean. That would be how we convert. Hopefully this seems simple enough. This is kind of a short video because the process for getting our answer is not long. I'll still put practice problems here in the description. Just keep in mind, key thing to remember here is converting from a decimal to a fraction is that the denominator is always going to be based off of your lowest non-zero digit. So try to practice problems. There are some that might be harder than others. I do try and throw some trick questions in there too. So check those out and I'll see you in the next video.